Hey guys, it's Mrs. Winger. Welcome back. Today we're going to be reviewing section 6.7, which is all about modeling exponential functions. So let's just jump right into it. If I give you 2 points and I ask you to give me a function, an exponential function that goes through or passes through those 2 points, we can do that. And so we know that every exponential has this function, this look of y equals a times b to the x power. Now luckily I already know here's one x and y, and here, let me do a different color, is a second x and y coordinate that goes through those 2 points. I already know that it passes through that. So let's use, starting with the first set of coordinates that I gave you, 1, 6, let's plug that in. 1 for x right here, and the 6 for y right here, and write down what we get. b6 equals a b to the first power. Now I'm going to solve this out for either a or b. Now looking ahead, it doesn't actually matter which one you solve it out for. It'll work either way. But looking ahead, it looks like it's going to be a lot easier to plug something in for a because there's no variable that I have to do. Whereas if I were to plug something in for b, I'm then going to have to take it and raise it to the x power. So when I do substitution in the future, it's going to be easier if all I have to do is plug it in for a. So for that reason, I'm going to solve this equation for a. So to do that, let's divide by b, and I get a equals 6 divided by b. Now I don't have like a nice easy number, but that was impossible to do because I had 2 variables in an equation. But that's okay, because now in step 2, I can take this x and y and plug it in, 3 for x, 54 for y, and for a, I'm going to use this value right here. So let's write that out. 54 equals a, which I'm using my substitution down here, times b to the x power, which is 3. And now we can solve this. First step I want to do in solving is figure out what is b to the third power divided by b. Well, remember, if it doesn't have an exponent, we know it's 1. Using basic exponent rules, that's going to be b squared. So I have 54 equals 6 times b squared. Let's solve this for b. I need to divide both sides by 6, which is going to give me 9 equals b squared. If I take the square root of both sides, I'm going to get that b is equal to 3. Now you might be wondering, why am I not writing plus or minus 3? And that's because this was our value. Remember, what we're solving for is b, and b in an exponential function can either be greater than 1 or in between 0 and 1 if it's a decay. Never, ever, ever do we have negative b values. So I know that I'm just going to take the positive value for b, which is 3. Okay, so we're almost done. I know that b is equal to 3. But I don't quite know what a is. But if you remember, way down here in step 1, we have a really easy formula for a. We know that a is 6 divided by b. So if it's 6 divided by b, then by plugging it in, it'd be 6 divided by 3, which is 2. So a is 2, b is 3. Let me erase my screen and write what our actual answer is. If you need to take a second and write down this work, go ahead and pause the video now. So we had just solved that b is equal to 3 and a is equal to 2. So just writing this down into this equation right here would look like this. Now if someone were to ask you if this is exponential growth or exponential decay, I would say it's exponential growth because of this value right here for b is a number that is greater than 1. Okay, so try this one on your own. Go ahead and pause your screen just so you can see a blank screen and look at these numbers and copy them down. I am going to write out step 1 and then pause it again, and then write out step 2 and then pause it again and write the final answer. So if you are getting stuck, you're welcome to hit play and get a hint for the first step. So my first step is just writing down my formula for an exponential function, y equals this part right here, y equals ab to the x power. And then I'm going to take my first coordinate pair, plug in the 2 for x, plug in the 12 for y, and I'm going to solve this out for a, because remember, it's a lot easier to plug things in here than it would be for b, since a does not have an exponent on it. Now that I have a formula for a, I'm going to plug that in for a, and this time, instead of using the first coordinate, I'm going to use the second coordinate given and plug in 3 for x and 24 for y, and that's going to be step 2. Take a second and work on that. So when I plug everything in, this is the equation that I get. The first thing I want to do to simplify is what is b cubed divided by b squared? That would just be b to the first power. Or you could just say b. And now I'll solve this for b by dividing both sides by 12, which gives me that b is equal to 2. If b is equal to 2, I still need to find a, but again, remember I have a really easy formula over here. A is equal to 12 divided by b squared. What is b squared? 2 squared is 4. 12 divided by 4 is 3. So if a is 3 and b is 2, I'm going to come up to the very top of the paper and write down my final answer of y is equal to 3 times 2 to the x power. So this is an exponential function. This would be exponential growth because that value for b is greater than 1. Alright, so let me remind you now how we can use our graphing calculators, and we're going to use the exponential regression feature on your calculator to come up with an equation that models this set. So now instead of just having 2 points that the equation goes through, I actually have 7 points that I know the exponential function is modeled by. It doesn't mean that these are going exactly through these points, but that these points are really close to being on the curve. So, follow along on your graphing calculator. On Google Classroom, I posted a link that you can download a graphing calculator on your computer. I did that and took screenshots of it for you guys, and it's a really easy link to download, and it'll give you like an access code that you want to keep up on your browser and then type in once you actually download the file. It's really easy. It took me like a minute to download. Let me know if you guys have any questions, but that's what I'm going to be using. Of course, you can always just use your regular calculator if you have it at home with you. So the first step is you want to hit the button on your calculator that says Stat right over there. That is the button you hit anytime we're working with statistics. So since we're doing a regression model, that is a statistical model because these points, again, are not exactly on the curve, but they're pretty much on the curve. They're very close to the curve. So we're using statistics here to figure out what is the best possible equation for this exponential function. So once you hit the button that says statistics, you are going to hit enter. It'll already be set up to be on this edit button. Once you hit enter, you're going to get a blank looking list like this. And so here's where you want to type in all of the x values that I gave in that first slide and all of the y values gave on that first slide. I'm going to go back so you can see those numbers. Pause your screen here and type those in. Once you type it in, it should look like this. Make sure that you have the exact same number of x's as you do y values. Otherwise, you typed something in wrong if they're unbalanced. And so once you have that, we want to start doing some calculations. So go back to the stat button right here, and you'll see the same screen that we saw again. This time we're done editing. We've already edited the information. We want to start calculating. So go over to the button that says Calc, and you're going to scroll down until you find the one that says EXP-REG. That stands for exponential regression. I know we're doing exponential regression because the problem told us to find an exponential model. So we know it's not going to be cubic or quartic or quadratic or line. So hit this button right here and you will see a screen that looks like this. This screen is just confirming that you want to do L1 and L2. Remember L1 and L2 were the lists over here. Some of you might have accidentally typed it in like L4 or L5, so just double check what list they're in. If your screen doesn't have L1 and L2, you could either reset your calculator. There's a button on the back that you manually push in to reset it, and you'll get L1 and L2 back. Or it's not a huge deal if you're not on L1, L2. Whatever list you're on, like let's say I'm on L4 and L5, then when you're on this screen over here, just type in L4, L5, and you can find those buttons over here in blue. So not a big deal, but just make sure that the 2 lists that are mentioned here are the actual lists where you type things in. Otherwise, it's going to be calculating the wrong list. From here, you just need to hit enter a bunch of times until you get a screen that looks like this. And this is telling us our very best value for A and our very best value for B. I can tell by the B value, since that is greater than 1, that this is exponential growth. So now I just take those numbers and write them down. So I'll go back to the original question and I'll write down our A and B value that we found on our calculator, and I'm rounding to 3 decimal places here just to get a pretty good accurate model. So now using this model, I can answer any future question it may ask, like this gave me information for years 1 through 7, but maybe it's going to ask me for year 20 or maybe year 100. And now, instead of having to just go one by one, all I have to do is type that number in for X and I'll quickly get an answer for Y. Alright guys, and that is it for section 6.7, and that actually wraps up our entire review of chapter 6. So you guys are good to go now to work on those review problem sets, and again, just make sure you're popping into office hours if you guys have any other questions.